So hello guys, welcome to chemistry class, and today's topic is matter. So basically every substance present in this entire universe is made up of particles known as matter, and in this modern world the matter is considered or is divided based on its physical state and chemical composition. But earlier they used to believe that matter, everything in this world is either composed of one of the panchatatvas. So the panchatatvas were air, water, sky, earth and fire. So earlier they used to believe that matter is made up of any one of these panchatatvas. Okay, but today we divide matter based on its physical and chemical composition. So let's see the physical composition of matter in today's class, and chemical we will see later. Okay. So the physical characteristics of matter are like this. So matter is made up of small particles, and these particles are moving continuously. Then there is a space between the particles of matter, and every particle of matter attract each other with the force of attraction between them. Okay, now let's study the states of matter. Obviously you all know this, but let's just revise them. So there are three states of matter, that is solid, liquid, and third one is gaseous or gaseous state. Okay, so solid state, consider the examples of this marker. They are rigid, have fixed shape, fixed volume, and the particles of matter are compactly arranged or closely arranged. But in case of liquid, the shape is not fixed. They take the shape of container and it is not rigid, and the particles are arranged with little bit space between them. But in case of gases, the intercellular or the space between the particles is more, that is the particles are randomly arranged in case of gases. But in case of gases, the particles are randomly arranged and they don't have fixed shape. Obviously they are randomly arranged, so they are everywhere, right? So let's take this small examples of three blocks. In case of solids, the particles are compactly arranged. They don't have intercellular space, or the space between the particles is negligible, that is no space. But in case of liquid, they have little bit space between them, not so much, but maybe more or less. But in case of gases, the particles are randomly arranged and can freely move from here and there. So this is the major difference between solid, liquid and gas. The best example I can give is that consider a cup of hot tea. Okay, this is a cup. Now the outermost cup is made up of solid, and inside there is a liquid, and tea is hot, right? So it gives gases. So there are two concepts regarding the matter. So based on that, there is melting point and one is boiling point. So basically melting point is one, or the point at which solid converts itself into liquid, and boiling point is one which liquid turns out to be gas. Okay, so the point at which solid gets converted into liquid is called melting point, and the boiling point is one where liquid gets converted to gaseous state. So remember these 2 points, melting point and boiling points. Now effect of pressure. Let's see what happens when we apply pressure. So when we apply pressure and reduce the temperature, we can liquefy gases. For example, dry ice, that is solid CO2. With pressure, the carbon dioxide which is in gaseous state is converted to solid. That is the effect of pressure. Dry is known as solid carbon dioxide. Okay, so that is the effect of pressure. Next comes the concept of evaporation. So evaporation is nothing but conversion of liquid state to gaseous state below its boiling point. Okay, that's very much necessary. Boiling point. The factors affecting evaporation is surface area, humidity, and wind, speed of wind. With the increase in speed of wind and surface area, evaporation increases. Okay, and last concept is that latent heats of fusion and vaporization. So here, amount of heat required to convert 1 kg of solid to liquid at its melting point is called latent heat of fusion, and here amount of heat required to convert 1 kg of liquid to gas at its boiling point is called latent heat of vaporization. That's all about physical state of matter. The last concept is that whether solids, liquids and gases, that is states of matter, are interconvertible or not. The answer is yes. How? So solid can be converted into liquid state by the process known as fusion, and liquid can be converted into solid state by the process of solidification. Similarly, solid can be converted to gases by the process of sublimation. Sublimation is nothing but solid can directly be converted into gases. Okay, and the process of conversion of liquid to gas is known as vaporization, and from gas we can convert to liquid is known as condensation. Consider the example of ice. Now it's in solid state. When you convert ice to liquid with some temperature, applying some heat, it turns out to be water, that's in liquid state. Now when you heat water till its boiling point, that says 100 degrees Celsius, it turns out to be vapor. This is known as vaporization, and it turns out to be a gas. Now when you condense these water vapors, they form liquid, and when you solidify liquid, they form solid. So yes, the solids or the states of matter are interconvertible, that is they can be converted from one form to other. Okay, if you like this video, do like, share and subscribe, and hit that bell icon for further notifications. Okay, bye bye.